Welcome to This Explainer. Today, we're diving headfirst into decoding the dark universe, the invisible detective mystery. We are going to explore literally the greatest mystery of the cosmos, the invisible scaffolding of our universe. If you think you know what's out there in the vastness of space, well, prepare to have your perspective entirely flipped. We're going to use the absolute latest data to track down a massive cosmic ghost. Okay, let's kick things off with a totally mind-bending question right off the bat. What happens when a galaxy is completely missing its stars? I mean, it sounds like a paradox, right? A galaxy without stars is kind of like an ocean without water. But to understand how this is even possible, we first need to look at the basic ingredients of our universe. To find the answer, just think about this breakdown. The ordinary matter, the stuff making up you, me, the Earth, the sun, and absolutely everything we can see with our instruments, is just a tiny 4.9% sliver of the cosmos. Meanwhile, the invisible ghost we call dark matter accounts for a massive 26.8%. It vastly outweighs normal matter. It's everywhere, yet it doesn't emit, reflect, or block any light whatsoever.
Which brings us to Section 1, the universe's biggest ghost.
You know, when we gaze up at that familiar starry night sky, we're really only seeing the glowing, regular matter. We're being blinded by the light, quite literally, leaving us completely oblivious to the massive dark voids that actually dominate the cosmos. The stars are basically just the shiny ornaments hanging on a massive, invisible tree. Let's move on to Section 2, Seeing the Invisible. So here's the million-dollar question. How do astronomers play detective and track down a cosmic suspect they can't even see? If it doesn't interact with light, how do we even know it's there? Well, we use the universe's ultimate magnifying glass, gravitational lensing. Thanks to Einstein's general relativity, we know that mass curves the fabric of spacetime. Even if we can't see the dark matter, we can definitely see its gravity warping space, which then acts like a giant, invisible optical lens.
Here's exactly how it works. Step 1. Dark matter clumps together in a massive unseen halo. Step 2. Light travels toward us from a distant background galaxy. And Step 3. The mass of that intervening dark matter literally bends that light. By studying these tiny distortions, a process called weak gravitational lensing, or cosmic shear, astronomers can reveal the invisible footprint of dark matter.
That takes us to Section 3, Enter the Ghost Galaxies. Armed with this amazing detective tool, astronomers started finding things that honestly just shouldn't exist. Astrophysicist Roberto Abraham asks us to imagine our Milky Way galaxy, but with almost all of its stars completely thrown away. That's his spot-on description of ultra-diffuse galaxies. These are incredibly faint, ghostly systems that are roughly the size of our own galaxy, but they're almost entirely empty of glowing stars. Get a load of this staggering number, 99.98%. We're talking about a candidate dark galaxy known as CDG2, located over in the Perseus cluster, and it's estimated to be composed of an astonishing 99.98% pure dark matter. It is almost entirely invisible. It's an absolute ghost. Now, what's really wild is how they actually tracked CDG2 down. They didn't look for a bright, glowing core because, well, it doesn't have one, but instead they spotted anomalous, tight clusters of stars, known as globular clusters, trapped within its invisible grip. The stars were essentially the tiny breadcrumbs that led researchers straight to the massive, invisible dark matter halo holding them together. To pull these cosmic ghosts out of hiding, scientists have brought up the big guns. From radio observatories like FAST in China and the VLA in the US, all the way to the Hubble and James Webb Space Telescopes. Webb is famously the $10 billion gamble that could erase modern science. And I say that because the unprecedented data it's pulling from these dark areas threatens to completely rewrite our foundational models of the cosmos. And that brings us to Section 4, Cloud 9, a failed galaxy. This incredible search actually leads us to a completely starless relic known as Cloud 9. Normal hydrogen clouds in space are sprawling, they're large, and they have highly irregular shapes. But Cloud 9 is strangely compact and highly spherical. Scientists have likened it to a hollow cosmic Easter egg just rolling through the universe, and there are literally 0 stars inside of it. So, what's actually keeping this hollow cosmic Easter egg intact? Well, it holds about 1 million solar masses of hydrogen gas, but that immense pressure is kept perfectly in check by a staggering 5 billion solar masses of dark matter. You know, in science, failures often teach us way more than successes. Cloud9 is essentially a primordial building block of a galaxy that failed to ignite. It simply didn't have enough mass to spark star formation, leaving it as this pristine relic.
Let's pull back for Section 5, Mapping the Dark Web.
Now that we've found these isolated ghost structures, it's time to zoom out and look at the macro view. Using that $10 billion scientific gamble I mentioned earlier, the James Webb Space Telescope, researchers mapped nearly 800,000 galaxies in a patch of sky in the Sextans constellation. By analyzing the weak gravitational lensing across all of those galaxies, they charted the invisible scaffolding that shapes our universe with twice the sharpness of any previous map. And what they confirmed is just absolutely breathtaking. It's this massive cosmic web. You have dense dark matter hubs connected by massive lower-density filaments. Dark matter really acts as the cosmic architect here. It dictates exactly where regular matter gathers to form stars, galaxies, and ultimately the heavy elements necessary for the origin of life itself. Without this dark web, we literally wouldn't exist. Finding untouched objects like Cloud9 is so vital for us. As astronomer Andrew Fox points out, this cloud is a window into the dark universe. By finding objects totally dominated by dark matter, completely untouched by the messy physics of exploding stars and glowing gas, we get a rare, unpolluted look straight at the universe's most elusive ingredient. We are literally just at the beginning of charting this invisible scaffolding. Facilities like the upcoming Roman Space Telescope are going to map an area thousands of times larger than we've done so far. So, as we peer deeper and deeper into these invisible halos, I want to leave you with one final, thrilling thought. What else is hiding in the dark?